All right, so these are the 3.3 notes. This is the last transformation we're going to go through in this topic. It is rotations, so we're going to be rotating around a point. Most of the time, it's going to be the origin, but sometimes we do rotate around certain points as well. Okay, so a rotation, right, is a transformation that rotates each point in the pre-image around a point P, which is called the center of rotation, and is rotated by a certain angle measure called the angle of rotation. Okay, the image of P is P prime, same as we did before. Okay, and for a pre-image point A, PA is equal to PA prime, because P doesn't move because that's the angle of rotation. Center of rotation. But A changes because, right, we know it's rotating around that point P. Okay, so a rotation is a rigid motion. So this is the last rigid motion we're going to go through. So its length and angle measures stay the same. All right, so what are the rules? Well, a 90-degree rotation counterclockwise, right? So when we do these, what we're going to do is think counterclockwise. So if I tell you to do a 90-degree rotation, you're going to do it counterclockwise. Okay. Unless I specify other words. Okay. So rotation 90 degrees counterclockwise, we use our x, y changes to, we're going to move our y as our x term, and we're going to take the opposite of it. Then our x becomes our y term. Okay. Right. So example, right. If we had 1, 2, our y becomes our x, and we take the opposite of it. So it becomes negative 2, 1. For 180 degrees counterclockwise or clockwise, either way is going to be the same. You take the opposite of both. So example, negative 4, 3 becomes 4, negative 3. And then the last one is 270 degrees counterclockwise, right? So this is actually the same as 90 degrees clockwise. Okay, but we always go by counterclockwise unless stated otherwise. And the 90 degrees counterclockwise is the same as 200 degrees clockwise. But for 270 degrees counterclockwise, our y becomes our x, and our x becomes our y, and we take the opposite of it. So example, right, negative 2, 7. Our y now becomes our x, so 7, and then we take the opposite of 2 to get our y term, because it's the opposite of x, becomes 2. Okay. Now, so this says, what is the rotation? So little r means rotation, stands for rotation. Right? We know big R stands for reflection. This O stands for around the origin. So those rules we just went through in the last page is only when it's rotated the origin. And this is the degrees counterclockwise we're going to go. Okay, so you can start with any point. So A, right, we know is at 3, 5. B is at 1, 7. C is at negative 2, 4. And D is at 2, negative 1. So 90 degrees counterclockwise tells us xy, right, becomes negative y, comma x. So our A prime becomes negative 5, 3. B prime becomes negative 7, 1. C prime becomes negative 4, negative 2. And D prime becomes positive 1 and 2. Okay, so let's draw our prime version. So A is negative 5, 3. So here's A prime. B prime is negative 7, 1. C prime is negative 4, negative 2. And D prime is 1, 2. Okay. We can see the shape and size is preserved. Therefore, we've done it correctly. Right? So essentially, we just move this around the origin 90 degrees, counterclockwise. All right, so what I want you to do is try this one. You're given the vertices of X, Y, Z. So what I want you to do is first draw X, Y, Z, then find X prime, Y prime, Z prime. So draw each triangle, right? Then find the coordinates of this and then draw. So pause it now, try these, and then I'll show you the solution. So the vertices are 4, negative 7 for X prime, Y prime is 0, negative 8, and Z prime is negative 2, 1 because you're doing 180 degrees, so XY becomes opposite of X, opposite of Y. So the signs essentially just change. All right, so let's just do some practice. All right, figuring out where STUV is. And then what I'll do is we'll go through like one of these, and then I'll let you try the others, and then I'll show you the solutions. So XY, we're going 90 degrees counterclockwise. That becomes negative YX. 180 degrees XY becomes negative X, negative Y. And 270 degrees XY becomes Y, negative X. So let's do 270 since we haven't done any of the 270. So right, S is at 0, negative 2. T is at 1, 0. U is at 3, negative 1. And V is at 2, negative 4. So if we take our Y, we get negative 2. If you want to, you could fill out all the Y's because you know they're not going to change and they're going to be the X values. So negative 2, 0, negative 1, negative 4, all move over to the X coordinate of the prime shape. Then we do the opposite of X, right? Opposite of 0 is just 0. Opposite of 1 is negative 1. Opposite of 3 is negative 3. And opposite of 2 is negative 2. So you'll just now have to draw that in here. So what I'll do is I'll have you pause this, try these, and then I'll show you the solutions. Okay, so here are the solutions and the drawings to them. So you can check your answers by pausing this and making sure you've done it correctly. Right, your STUV is the same for each question. You're just changing. And one thing you can notice, right, 90 degrees counterclockwise is most likely going to end in the quadrant, like essentially to the left of it. 180 degrees is going to be like the opposite quadrant if it's like in a certain quadrant. See how it's all in quadrant 4, our original one, right? That means we're going to move back left 1 for 90 degrees, which puts in quadrant 1. 180 degrees, we'll put it opposite, so that'd be quadrant 2, and then 270 goes through 3 quadrants and lands in the 3rd quadrant. All right, now I want you to try these again, right? Again, right? We get opposite of Y, X, opposite of X, opposite of Y, and Y opposite of X. So I'll pause this, have you try it, and I'll show you the solutions. So here's the solutions, right? Just follow the formulas, and you should get your ordered pairs. So this is just, if you're asked for the ordered pairs, you don't need to draw it if there's no like graph. The last part of 3.3 is writing the function given the pre-image and the image. So what we're going to do is we're going to first just pick one of the original points, so I in this case, and then we're going to write our I prime or our image, right? That, and then we're going to see if X and Y swapped, right? If they don't swap, then we know it's got to be 180 degrees. If it does swap, it can be 90 or 270. right? And then we can see by whose signs change whether or not it's 270 or 90 degrees. Okay, so right, I right here we can see is at 3, -1, and I prime is at 1, 3. So did X and Y swap places? Yes, they did. So it's either 90 degrees or 270, right? Whose signs changed? Well, this Y, right, changed here, okay? The Y value changed, right? So we know we take the opposite of Y when doing 90-degree rotation. Okay, so we know we figured out it's been a 90-degree. Remember I told you if it kind of moves one quadrant, you're most likely going to have a 90 degrees, but we just have to check it. And the way we write this rotation, right, is a small lowercase r, 90 degrees about the origin. Okay, so O. The next one, right, let's try Y. Y is at -1, 3. And I prime is 3, 1. Y prime. So, did X and Y swap places? Yes, they did. All right. Whose signs changed? Well, X was -1, then it became 1, so our X value. So we know, right, this was XY changing to Y -X, which is a 270-degree rotation. Right, remember this one, right, we had XY change to -YX, which was 90 degrees. So again, it's R, 270 degrees about the origin. Last one, X, right? In this one, you could tell as well, right? We run around 3, so most likely 270. And this one, our X is at -5, 2. And our X prime is at 5, -2. Did they swap places? No. Right, therefore, most likely, right, 180-degree rotation. And again, both changed. So XY changed too. Right, they didn't move, but we took the opposite of both. Right, that tells us it's a 180-degree rotation. So it's a rotation of 180 degrees about the origin. Right, and this is what you'd want to put in for your rotation. And that's it.